Hello folks, we come to the part 2 video of this exercise, miscellaneous exercise of this chapter, and three very important problems, very important from understanding point of view and working point of view and all that. Let us see what it says. The problem number 4 says that there are 10,000 in a certain lottery, 10,000 tickets are sold and 10 equal prizes are awarded. So there are 10 tickets which is going to get prizes, that is the meaning. What is the probability of not getting a prize, if you buy 1 ticket, 2 tickets and 10 tickets. So these are the three cases where you have to find the thing. Now 10,000 tickets are there, only 10 is winning the prize. So the tickets which are not winning the prize is the difference of these two. So on the basis of that, we have to solve and get the answers for this. Here, number of tickets not getting the prize. Not getting prize is 10,000 minus 10. How much is that? 10 minus 1, 990. Every time the sample space is going to change for every subpart, because every time the number of ticket is different. So sample space is going to change. So the number of tickets not getting the prize is 9,990 for some case when there is only 1 ticket, right? So therefore n of s, sample space, when s is sample space, n of s in this case, because we are looking at not getting the prize, it is going to be 1 amongst the 9,990 ticket. So it is going to be 1 amongst them. Now because there is just this 1 ticket, that is why we are writing C1. Now A be the event, let the probability how can sample space be that? Yeah, very sorry, sample space is not that. Sample space is amongst the 10,000 tickets, 1 is chosen, right? So that's a sample space. Okay, let A be the event that we don't get the prize. Let A be the event of not getting a prize. Right? So that is from, it has to be 1 amongst them, because these are the cases where it's all going to get a prize. So it is 9990C1. Okay, these are the cases where you don't get a prize. So the required probability is n of A by n of S, which is 9990C1 and 10,000 C1. But luckily we have studied NC1 is n, right? So we can call this as 9990 by 10,000. And the zeros will cut, your answer will be 999 by 1000. Right, that's the first case. Second case, when you have 2 tickets, that time your n of s will be 10,000 C2, because from that 10,000 tickets you are choosing the 2 tickets, and then we will specify the events. B be the event of not getting a prize. Right, if you have to not get a prize, means obviously you have to take a pick from the 9990, right, because it is categorized for not getting ones, and amongst those there is going to be 2 tickets which is going to satisfy your requirement. So it is like this, like that. The probability of B is going to be 9990C2 by 10,000 C2. Same way we are going to do the third part where we have 10 tickets, right? Here n of s will be 10,000 C10. Okay, and we take the event, let C be the event of not getting a prize, right? So let's borrow some space here. N of C is going to be 9990. Not getting means we are going to resort to this 9990 C10, like that. The probability of C is n of C by n of S, and that is 9990 C10 by 10,000 C10. That's it. That's how we are going to do this problem of not winning a prize. Okay, so that's about it. Otherwise, you can do one thing is 1 minus probability of winning a prize. That way also we can do. Now we have this next question, okay, very important. We have the same kind of question coming again in the 12th standard. Here they say that there are 100 students in a class. Out of 100 students, 2 sections are formed of 40 and 60. If you and your friend are among the 100 students, what is the probability that you enter the same section or you enter different sections? That's a question. So suppose say that this is section A and this is section B. Question is if you enter the same section. Either you enter section A or you enter section B. Now, let us get the sample space. Right. So, n of s is from the 100, we are looking at the entry of these 2 students. So, it is 100, choose 2. Okay. Now, let A be the event that both of them enter the same section. Same section. When you do that, you have to consider 2 cases. Case 1, they enter section A. Case 2, they enter section B. Now, if they enter section A, the number of ways in which they enter section A is 40, choose 2, because they have entered there, right? In the number of ways in which amongst the 40, these are 2 people. So, you got the 40 choices, right? So, it is 40 choose 2. And if they are entering the section B, then the choices that they are provided with is 60. So, these 2 students are entering there and there are 60 choices. So, this is the number of ways. So, if you want, you can write the problem. If a probability is going to be 40 C2 by 100 C2, and this is probability is going to be 60 C2 by 100 C2. Right. Now, therefore, probability of A is a, see, when you have 2 cases, the probability will be the sum of those 2 probabilities. So, we will have 40 C2 by 100 C2 plus 60 C2 by 100 C2, which is 40 C2 plus 60 C2 by 100 C2. Let's solve this. 40 factorial by 2 factorial and 38 factorial, 60 factorial, 2 factorial and 58 factorial, 100 factorial, 2 factorial and 98 factorial. Right. So, 2 factorial from everywhere, I think it will get cancelled by taking it common. And then here it is like 38 factorial into 39 into 40, right? 58 factorial, so it is now 39 into 40 here. Here it is 59 into 60. Then here it is 99 into 100. 2 factorial from everywhere, we take it out common and we cut it, right? So, like that is sorted out. Okay, then so the remaining things what we will do, I think we can take a 30 out if you want, 3 from here and 10 from here. If we take a 30 out, then what is remaining? 13 is remaining. 13 into 4, 52 is remaining here. And here if you take a 30 out, then 2 is remaining. So 59 into 2 is how many? 9, 2s are 18, 1 carry, 5, 10, 11, 118 by 99 into 100, out of which 0 can cut, 3 can cut, 33 times. Right. Now let's add this and see how much is coming. 8 plus 2, 10, 1 carry, 6 and 1, 7. 170 by 30 actually. Cut, 17 by 33. So, number of ways in which these 2 girls have entered or these 2 people have entered the same section is 17 by 33. Why? Because if they are entering section A, there are 2 people who is entering section A, and for section A we have got choice of 40. There can be 40 people. These 2 have entered. So, out of 40, these are 2 people. In how many ways it can be done? It can be done in 40, choose 2 ways. Same way, out of 60, these 2 people have entered. So, in how many ways that can be done? It can be done in 60, choose 2 ways. And totally, whenever we have sub cases, as I said, we will add it up, and this is what our answer will be. Now, the second subpart, that both of them enter different section. If you look at section 1 and part 1 and part 2, they are complements of each other, right? So that is why we can just do 1 minus and get the answer. So I will let you know this over here. This is for part 2, okay? So for part 2, let B be the event that both enter different section, but B is A complement. Therefore, probability of B is 1 minus probability of A. Like that, it is 1 minus 17 by 33. We equalize into 33 into 33. 33 minus 17. 13 minus 7, 6. 2 minus 1, 16 by 33. Okay, second subpart, the answer is 16 by 33. That's about question. Very interesting. And very interesting, not only interesting, very technical. Why? Because there are two odd problems in the 12th standard textbook which is on the same lines, right? So unless we have this, it's not going to be easy there. That's about this. That's about the 5th question. Now let's quickly move to the 6th question. Now in the 6th question, what they say, that there are 3 envelopes and there are 3 letters. So a particular letter, for a particular letter, there is a particular envelope that is assigned. But there are different. Now see, if you have those 3 envelopes kept there and 3 letters, a person, without seeing if you are putting, you can put it in so many different ways. So out of the different ways, find the probability of getting at least one letter in the proper envelope. You should find out all the cases where at least one letter has gone into the proper envelope. That is a question. See, you can also do this like this. No letter has gone in the proper envelope. You do and do 1 minus, you will get the answer. That way also it's correct. Okay. So for this, we will just, for our like easiness, we'll say that let A, B, C represent the envelopes and X, Y, Z represent the letters. Right. Now the different ways in which you can do the inserting. Okay, it is like we are not going the other way around. We are just looking at the pictorial version of it and then we are going to write the answer. So you should give me some time to just draw it. We may require, but let's see. Now these are our envelopes. A, B, C. A, B, C. A, B, C. Okay. First case is where we insert everything properly. Okay. So here X will come, here Y will come, here Z will come. We have inserted it properly. All are proper. Okay. Then only one is proper. So only one is proper means X is proper. So this is not proper. If this is not proper, here it is Z and here it is Y. Okay. Then one is proper means here it is Y. So here it should be Z and here it should be X. One is proper means here it should be Z. Then here it should be Y and here it should be X. Right. One is proper. See, two proper case will not come. If two envelopes have got two proper letters, then the third has to be proper. Right? Let's logically think. If two will be proper, then automatically third has to be proper. So that case will not come. What we are doing is, this is our sample space. We are listing everything and then from there we will sort out whatever is required. Then, so this is case. These are all different cases. Okay, so what we have done, one is proper, none is proper. Okay, nothing is proper. So for example, like A can be having it has got, suppose A has got Z here, then B can have X and C can have Y, right? Also A can have a Y. If A can have a Y, we had BX and CZ, BZ and CX. Just a matter of thinking, getting different cases. So these are all the ways in which you can insert these letters in a proper case, when there is one proper, when there is no proper, right? Now see, these are all the different possibilities: possibility 1, possibility 2, possibility 3, possibility 4, possibility 5, possibility 6. What is this possibility when all are correct? Okay, possibility 2, 3, 4 are when one is correct, right? And possibility 5 and 6 when nothing is correct. AZ, BX, CY, AY, BZ, CX. Nothing is correct. You can just rack your head and find out if there are other cases. I have racked mine and I have concluded that only so many will come. So these are the cases. So how many cases are there for us? 6 cases. So what is our sample space? Sample space is 6. If you have to get probability of at least one letter, it is enough if you get 1 minus probability of no letter. That way also it will do. So that is 1 minus 2 by 6. That way also it is okay. Otherwise you take at least 1 plus, that means 1 and 3. 2 cases and then do it. That way also it's correct. So both ways it's correct. Now we'll write here the n of s is 6 cases. 6 ways of inserting. We found out that there are 6 ways of inserting. Probability, therefore, probability of at least, see, we could have written it in this event form AB, but I don't know, it become too lengthy. So if you want, we can do it, or I don't know what we should do. Should we do it, or yeah, because we've been doing it like that, I don't want you to confuse you by a different method. So let's list and find out. Let A be the event of A is already there, isn't it? So E is there anywhere? No. Let E be the event of having at least one letter in the proper envelope, and F be the event of having no letter in the proper envelope. Okay. Let's go there. But E is F complement. They are complements of each other, right? So therefore, probability of E is 1 minus probability of F. Whenever we have to complement events, to get one event, it is enough if you do 1 minus a probability of its complement. So that we are taking. Why we are taking? Because we know that the cases where none of the letters are in its correct envelopes are just 2 cases. So this is 2 cases out of the 6 cases. That's how you are getting your probability. So when we equalize, it is going to be into 6 into 6, 6 minus 2 by 6, which is 4 by 6, that is 2 by 3, right? So the number of cases in which these letters are not in its proper envelopes are, the number of cases in which at least one letter is in its proper envelope is 2 by 3. So that's of course you can do it in C1 and that kind of a thing, but I thought this is more pictorial and more practical, very easy to understand. So I thought probably we could resort to this method. That's about it. Remaining problems in the next video. Thank you.